Okay, so for our lines of reflection, we've already done this one. A line of reflection. If you can fold it over that line, it matches on top of itself. That is a line of reflection. How many did you get for the first one? 1 is correct. This is the only line of reflection. If I fold it over that line, the triangle maps onto itself. I cannot do this because this corner down here, it's going to kind of go up there if I fold it over. So that wouldn't work. You just kind of have to eyeball it. This one does end up having 6 of them. Sometimes they follow a pattern. So if I can go from that vertex to that pointed vertex, maybe all of the vertices will work that way. There's 3. Then I could go like that. If I fold it on that red line, this corner will end up there, that corner there, everything works out. Again, kind of follow that pattern. If it works from that inside point here to this one here, maybe there's more that work like that. This right here, be a line of reflection, and that right there. If it ever says how many lines and you're having trouble counting them, just go in a circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did you notice I counted each line twice? So then 6 lines. It might say draw them, state how many. Just go in a circle and count them up. This hexagon here, 1, 2, 3. Those kind of line up or match. And then I also have, if I go from the center here to the center here, picture that folding on that blue line. That would match up. And then I'm just going to kind of follow that pattern. Here's another one. Another one that also has 6 lines. How many for the last figure? 2. Okay. Let me erase what I have. So, is this a line of symmetry? No. If I were to reflect that, this point here is going to go about right there. It's not going to go on top of itself. What about, is that a good one? No. So maybe diagonally. That looks good. And that looks good. So yes, you were correct. There are 2. Okay, now we're going to actually do some reflections on the coordinate plane. Sometimes students find it hard to find the line. Sometimes this is harder to figure out what line we're reflecting over, harder than actually doing the reflection. Here's why this is difficult. The y-axis is right here, up and down. Y equals 1 is actually horizontal. The y-axis is up and down. But if I want to go to a height of 1, this is a line that has a height of 1. Go ahead and draw that in on your paper. It can be dotted or solid, whatever. If you like a highlighter, red pen, I don't care. Yesterday we did translations. We just slid it around, left, right, up, down, diagonal. Today we are flipping it like a spatula and a pancake, flipping it over. Here's how you do that. You can watch and then I'll give you time to draw it. To do reflections, you simply walk to the line and then walk the same on the other side of the line. So if I take A and I walk to the line, that's 1, 2 units to the line. Now I do that exact same thing on the other side of the line. 1, 2. Walk to the line and then walk past it. Everybody do A prime on your paper. Let's look at W. I'm going to walk to the line. 1, 2, 3 units. Do the same on the other side of the line. 1, 2, 3 units. Go ahead and do the last 2 points also. Don't forget to connect it when you're done. Is this something we've done before? Good. Yesterday when we did translations, do you remember that everybody walked the same amount? Like if the band moved to the left 2 and down 4, every person in the band went left 2 and down 4. Does every person move the same in a reflection? Well, let's look at A. How far did A travel down the field? 4 units. Is that how far M traveled? No. We all reflect over the same line, but that doesn't mean we all move the same distance. Let's do number 3. Reflect over the y-axis. So draw in the y-axis. Let's reflect points one at a time. It doesn't matter where you start. I'm going to start with L. You're always walking to the line, perpendicular to the line. So here we go. L. 1, 2, 3 units to the line. 1, 2, 3 units on the other side. B. B is on the other side of the line. That's no problem. It's 2 units from the line. 1, 2. So I go 2 units on the other side. Do J. What's going to happen with W? Not going to move. It's also W and it's also W prime. It's both. Okay, go ahead and connect them. It may look more confusing because they're kind of on top of one another, but it's still reflecting. Walk to the line, walk past the line. Number 4, reflect the arrow over the line x equals 4. Go ahead and draw this line of reflection. X equals 4. We're going over 4 in the x direction. This line is x is 4. In the last 2, we had specific points. 4 points here, 4 points here. This one, we don't have specific points, but you can just pick whatever points you want. You can match mine if you want. I'm going to go with the pointed part of the arrow is A. This top vertex as B. Kind of the base, the bottom of that flat part C. And then D. If you want to do more points again. Reflected just like the last one. I'm going to start with A. A is 1, 2, 3, 4 units from the line. 1, 2, 3, 4 units. Go ahead and do the rest of them. C stays in place. We call that remains fixed. C remains fixed. It's in a fixed spot. It didn't move. Please don't do this. Your arrow did not just become a rhombus. We have to make it look like an arrow. So look at what you had. A was the pointed part. So make A the pointed part of the arrow. C was located at the base, so I'm going to kind of draw the base again. Then you just have to freehand the rest. So the base extends and goes out, extends and goes out. It should look like an arrow. Does it have to be perfect? No. It should look about the same size and shape. As close as you can get it. All right, please do number 5 on your own. I'll work on it up here as you're working. Which letter moved the least amount of spaces? D. Which letter moved the most spaces? B. Make sure you have it labeled correctly. Go ahead and read 6 to yourself and see if you can figure out the answer. The directions are different. You're not actually reflecting. If you don't want patty paper today, just leave it and I will pick it up at the end of the hour. Okay, number 6. What line of reflection? What line of reflection would map the arrow onto itself? Raise your hand if you have an answer for number 6. 1, 2, 3. Only 3 of you have an answer? What'd you put? X-axis, okay. So if I flip the arrow over this, the arrow's going to end up down here, right? I want to know what line of reflection would map it onto itself. What do you have? The y-axis. If I flip the arrow over the y-axis, won't it end up over here? What do you think? Okay, so give me you're there.
Y3.
Y equals 3? Yes. If I draw a line at a height of 3, and I flip that arrow over that line, it's going to land right on top of itself. Good, that is the answer. just have to say what line. Who else had their hand up? Is that what you had? Sure. 7. Students always get confused by the wording of this question. I'll read it and I'll break it down if you need help. What is the image of point C under a reflection across the line of symmetry? You will see this exact wording on a quiz or test. What is the image of point C? That means I have given you the pre-image. I'm asking you what the image is. What's the after effect? Under a reflection. So don't translate it. Don't rotate it. Reflect it. Across the line of symmetry. So what am I reflecting over? I'm reflecting over this line of symmetry. Do we understand the question? Where's C gonna go after I flip it on that line? And what is our answer? Yeah, it's just simply, it's gonna run over there to point A. B, does any point remain fixed under a reflection across that line of symmetry? So C moved, A moves, does B remain fixed in place? Yeah, all I have to do is say point B. C, which sides of the triangle must be congruent? Write down what you think. This is what students always tell me. This is wrong. They tell me this side must equal this side. Now, they're not entirely wrong because those parts will be equal. But look at my triangle. My triangle has 3 sides. Do you see why that answer is wrong? The question is, which sides of the triangle? Does the blue match the red, the blue match the green, etc.? So, of those 3 sides, which will be congruent? AB, when it gets flipped, is going to map right on top of CB. So, of the 3 sides of the triangle, AB is congruent to BC. Nice to put the segment bars above it. Congruent means equal measure. Raise your hand if you were gone yesterday. Okay. All right, so we're going to do what we did yesterday with the patty paper. So you are tracing it out. Remember, you're using this patty paper for probably 4 questions. So spatial awareness. You're going to copy this. Remember, as you trace it, put the letters on the inside because you're about to cut it out. Yeah. So that's basically the only thing to do. And cut right on the line. Don't let it cut around. If you want to try reflecting without patty paper, do it. I'll draw mine. I'll talk through. You can keep working if you need to. I'm just going to walk to the line. So A, I walk to the line, and I do the same thing on the other side. Walk to the line. C and D remain fixed. You can see mine got a little bigger. If it's really close, I wouldn't take off. When you're freehanding it, it's hard to get it exactly. You're kind of on your own now. You're working on 8, 9. 10 and 11 will be hard to trace because there's things on the inside. But go ahead, give it a try. I'll give you a couple minutes to do 8, 9, 10, and 11. Oh. Sure. Whole thing. Just leave your stuff. They want to keep it.
Why?
It'd be about.
Here's even if you still need this slide for 8 and 9. Okay, let me talk about 10. So the eye is pretty easy to reflect. I'm just going to go to the line and go past it. So there's the eye. Now you have to be careful with this right here. A winking eye. We can't just do this because that would be a translation. If I slide it down, that's the way it's going to be oriented. I'm not sliding the eye, I'm flipping it over. So I have to imagine if I flip that over, what it's going to look like. It's actually going to be that direction. Okay, let's look at the nose. We can't do this because that's oriented the exact same way. That's just sliding it down. We're not sliding or translating. We are flipping, reflecting. So it would look like this. If this is hard for you, you need to figure out a way to do the patty paper so you can actually flip it. In your mouth, like that. Okay, work on 11. So the eye moved farthest away. The winking eye did not move as far. It's right by it. Make sure your nose flip-flopped.